Hello and welcome. This is your science news briefing for January 19th, 2026.
Okay, let's dive right in. Today we've got some incredible stories for you. From a monster galaxy that's rewriting the rules, to earthquakes on a chip that could totally shrink your phone. We're also looking at superbugs evolving in space and the end of a decades-long hunt for a ghost particle.
All right, first up, we're heading way back in time. There's a new discovery from the early universe that's got astronomers scratching their heads and, well, basically rethinking everything they thought they knew about how giant galaxies come to be.
So get this. Scientists using the ALMA Observatory have spotted this giant galaxy called J0107a. The incredible part is, we're seeing it as it was just 2.6 billion years after the Big Bang. And it's a barred spiral galaxy, which means it has this really distinct bar of stars right through the middle, something we thought only happened in much older, more mature galaxies. And this thing is an absolute beast. We're talking 10 times more massive than our own Milky Way, and it's just cranking out new stars about 300 times faster. It's just nuts.
And that's really the kicker here, the age. We are looking at a snapshot from 11.1 billion years ago. To find a galaxy this well put together, this structured, with a perfect bar of stars, so early in the universe's life, well, nobody thought that was even possible. It's seriously like walking into a nursery and finding a fully grown adult just sitting there. It completely upends the timeline.
You see, the old thinking was that these monster galaxies were born from pure chaos, right? The idea was they formed when two or more smaller galaxies smashed into each other. This violent collision would supposedly funnel a bunch of gas to the center, and boom, you get a massive burst of star formation. But here's the thing, J0107a shows zero signs of any kind of collision. None.
So, the new theory? It looks like this galaxy is, well, it's feeding itself. That huge bar of stars is acting like a giant cosmic stirrer, pulling in gas from this massive disk that surrounds it and just creating its own self-sustained storm of creation. This totally changes the picture of how the universe's first giant galaxies grew up. It suggests they could form way faster and much more neatly than we ever thought.
Okay, let's zoom all the way in now. From the cosmic scale right down to the microscopic. We've got a breakthrough that could have a huge impact on the tech you carry around in your pocket every day.
So, a team of American engineers has built something they're calling a phonon laser. Now, instead of shooting out light like a normal laser, this thing produces and controls phonons. And what are phonons? Basically, they're tiny, incredibly high-frequency sound vibrations. The best way to think about it is like creating perfectly controlled microscopic earthquakes right there on a computer chip.
So what's the point? Well, the big goal here is to shrink down all the stuff inside our phones that handles wireless communication. If you can use these tiny sonic vibrations to process signals, you can get rid of a lot of the bulkier electronic components we use now. And that could mean, you guessed it, much smaller, more efficient devices for all of us.
All right, next up, we're heading into space, to low Earth orbit, where it turns out life is evolving, and in some really unexpected ways.
So, scientists had this question. What happens when you take that constant battle, that evolutionary arms race between bacteria and the viruses that hunt them, called bacteriophage, and you put it in space? How does microgravity change the game? And the answer is fascinating. The viruses that went to space actually evolved to become better killers. They got more effective at infecting and destroying the bacteria than the ones that stayed here on Earth. It seems like the unique pressure of microgravity actually pushed them to become more potent. And, that could have some really powerful implications for how we develop new ways to fight bacteria right here on the ground.
And finally, we've got an update on a huge mystery in the world of fundamental physics. The case has been closed, but maybe not with the answer a lot of scientists were hoping for.
So for decades, physicists have been on the hunt for a hypothetical particle called the sterile neutrino. It was this idea for a fourth type of neutrino that could explain some really weird, puzzling results they were seeing in their experiments. To finally settle it once and for all, they built this massive experiment at Fermilab called MicroBoon, designed for one job: find this ghost particle. Well, after a decade of searching, of sifting through just incredible amounts of data, the result is in, and it's definitive. The particle, it just isn't there. Now that might sound like a failure, but in science, this is actually a huge result. It means one door has closed for good, which forces researchers to get creative and start looking for brand new ideas to explain the deep mysteries of our universe.
Phew, okay, that was a lot. So let's do a quick recap of what we covered today.
So, we started with an ancient galaxy whose very existence is rewriting our theories of the cosmos. Then, we looked at new phonon lasers that might lead to much smaller gadgets. We also saw how viruses can actually evolve to become super killers in space. And finally, the long hunt for the sterile neutrino is officially over. And it turns out it was never there to begin with. Some pretty incredible stuff.
And that's your science briefing for today. Another update will follow in 24 hours.
Hey, if you enjoyed this and want to stay up to date, please do us a favor and hit that like and subscribe button. It really helps.